These are the steps to set up an optimization in SystemVue or Genesys. The circuit comes from a very famous example that ships with the product. If you'd like to follow along, look for an example called Intermod with Optimization. It's an amplifier chain, and we want to optimize the circuit so that the gain is exactly 10 dB, and the intermod level at the output is less than minus 95 dBm. The steps are always the same to set up an optimization. There are 3 steps. Step 1, you have to create at least one tunable variable. Here on the equations page, we're setting up 4 variables with initial values. They are made tunable with the tune function, which has been added to the basic MATLAB by Keysight. And any variables you create here will show up in your tune window. So that's step 1. You must create at least one tunable variable. Step 2 is to use the variables on your schematic. So zooming in on the first amplifier stage, it's using RF1 gain and RF1 P1dB. And these variables are entered right into the parameter fields. These other variables are derived from the other 2. The same is done on the second amplifier stage. It's using RF2 gain and P1dB. So step 2, use your variables on your schematic. Step 3 is to add an optimization, which you will find under Evaluations. Opening up the optimizer, most of your work is going to be done on the Goals and Variables tabs. First, the goals. Here, you write an expression in MATLAB to describe your goal. On line 1, we're saying we want the total third-order intermod channel power, TIM-CP3, at node 2, which is our output node, to be less than minus 95 dBm. And the extract swept data function lets us pull a measurement from a data set along a path, but only worry about one node. So we're only interested in the value of TIM-CP3 at the output node 2. That's what extract swept data does for us. It is another function that Keysight has added. On line 2, we're doing the same thing for cascaded gain, equal to 10 dB. The Variables tab is where you specify which variables you're going to allow to vary to try to meet this target. Here we're selecting all 4 of our variables. They've all been enabled for optimization. After that, the only thing left is to start the optimizer. And here we have a convenient table with measurements so we can monitor the progress of the optimizer. In particular, we're interested in the column of C gain, cascaded gain. We're interested in the last node. And at TIM-CP3, also at the last node. So we can watch the progress of the optimizer. And if it gets close, or if we are satisfied with the values, we can stop the optimizer and accept the tuned values. So you can see here, it's trying to drive the gain towards 10 dB. It's there, while keeping the intermod below minus 95. If we're happy with these numbers, we can stop the optimizer and accept the tuned values here in the tune window. Once again, this is a shipping example. Look for intermod with optimization. That is how you set up any optimization.